we're talking about combining like terms. And you may be thinking to yourself, what in the world is a term? Well, let me tell you, it's not too tough. A term in algebra is a number. So it can be a number all by itself. It can be a variable all by itself. Or it can be the product of a number and variables. So they can be multiplied together. This expression here that you can see is an example of an algebraic expression that has three separate terms. So that means this is a term, this is a term, and this is a term. And notice I did keep the signs attached to the term. That's part of the term. And when we're making terms, there's several different parts to a term. So let's take a look at what we're talking about with those. The first thing that I want to tell you about is a coefficient. A coefficient is what's called the numerical factor of a term. What is that? Well, it's this part. It's like the 2 and the positive 4. Basically, it's the number that is being multiplied, because it's a factor, and that's what factors do, they get multiplied. It's the number being multiplied by a variable. That is the coefficient. So we'll highlight that in green. So the coefficient is the number being multiplied by a variable. Sorry, that was off screen a little bit. It's, for example, the 2 and the positive 4. Those are all coefficients. Well then, what about this lonely number? This lonely number all by itself doesn't have any variables. That's called a constant. A number term with no variable, because it will never change. Remember, the variable is what we don't know. It could be anything, okay? And so it's going to change the value of the term no matter what we're multiplying it by, depending on what the variable is. Well, this term doesn't have any variable. It'll never change. It'll be negative 12 always and forever because it's not multiplied by anything that is changing. So, a constant is a number without a variable. A number without a variable, that's a constant. When we're talking about combining like terms, you'll hear me refer to the coefficient of a term, and you'll hear me refer to constant terms, okay? So let's talk then about what, if these are terms, what are we talking about when we say that we're going to combine like terms? Well, it's kind of like categorizing or putting things together, grouping things together that are similar. So how do we know if two things are like terms? Well, like terms have exactly the same what? Exactly the same variable factors. So the variable part of the term is going to be exactly the same. That's how we group them, okay? So for example, we might have 3x and negative 2x. The variable here is exactly the same. It's both x. We might have negative 5x squared. Now it has an exponent, so a like term might be 9x squared. Again, they're the same because the variable part is both x squared. Let's do some more. How about xy? Now we have two variables, but that's okay. It can still have a like term as long as the term has exactly the same variables, in this case, xy. Now, we can also have lots of exponents. We might have negative 7x squared y cubed. Whoa, that is a crazy term. But it can be grouped together as well, as long as the exponents on the variables are exactly the same. So 15x squared y cubed is a like term with negative 7x squared y cubed because the variable parts, this part and this part, are exactly the same. So then what would make a term not be like terms with something else? Let's take a look. For example, if you have 8x and 7y. Okay, these both have one variable, but they don't match, so they're not the same. We wouldn't group them together. You might have 5y and 2y squared. Well, now we have y in both of them, but one is a regular y, or y to the 1, and one is y squared. So they're not exactly the same. They can't be grouped together. 6y and 3xy. Again, they both have a y, but they're not exactly the same, so we can't group them together. Then we might have x squared y and xy squared. They both have x and y, they both have a square, but they're not exactly the same, so they don't get, okay? So looking at our term, none of these, or our expression rather, none of these are like terms with anything else, because this is a constant term, it doesn't have any variables. This is a squared term, it has a y squared, and this is an x term. It doesn't match the variable in any way. So these are not like the others, we're not going to group them together. So let's take a look at some examples of what it looks like when we do group them together. You will need your highlighters for this video, so if you don't have them, pause the video and take some out. I would recommend at least 2, maybe 3. So pause and get ready and come back when you're ready to jump in. Let's take a look at number 57. The first thing that you're going to do when you are combining like terms is you're going to color code them, and this will really come in handy with helping you to see where the different terms are, okay? So we're going to start at the left and we're going to highlight the first term. This is a coefficient with a variable of k. So I'm going to look and see, do I have any more? Here's one. I see that there's a variable of k, and it has a coefficient as well. Notice I highlighted the sign attached to the term because those go together. Now, positive 2 is a constant term, and negative 7 is also a constant term. So I highlight those in the same color. Now I can go back and combine. You always start with your variable terms. So we're going to start with our green terms, our k terms. I have positive 8 and positive 8. When I combine those together, I'm trying to keep my hand out of the way here. When I combine those together, I'm going to get positive 16, and the k tells me what term I'm talking about. This is the k term. How many k's do I have? I have 16 of them, so they stay together. Those are done. Then I have positive 2 and negative 7. Different signs, subtract, keep the sign of the bigger one, and then you're done. So when we combine like terms here, we have 16k minus 5. Let's take a look at 58. Again, I'm going to go through and I'm going to highlight my variable terms with their coefficients and my constant terms with their signs, keeping those signs attached. Starting with my variable term, I have 2 and positive 5. That gives me 7a, and I combine those two, and they're done. And then negative 10 and positive 1 gives me negative 9. Different signs, subtract, keep the sign of the bigger one. So 7a minus 9 is the simplified version of these 4 terms. We simplified them by combining things, putting like things together. All right, so here we have a variable term with a coefficient and a variable term with a coefficient. That's okay. They're both variable terms with coefficients. We're going to combine them. So here I have a negative 9, and here I have, well, wait a minute. There's no number there, just a negative sign. Well, how many x's do I have? I have 1x. So this is 1x. A negative 1x to be exact. So negative 9 and negative 1 gives me negative 10x. Let's take a look at another one. Let's see, here's a constant term and a constant term and a variable term with a coefficient of negative 6. I'm going to start with my variable term, and there's nothing to combine it with, so it stays the same. That one's done. Now I have positive 1 and positive 7 to give me positive 8. How about for 61? I have a variable term with a coefficient of 3 and a variable term with a coefficient of 7. Combine the coefficients, 3 and 7 together makes 10, and that's my n term, so n is my variable there. All done. I have a constant term of 3, a constant term of positive 9, a variable term with a coefficient of negative 10, and a variable with a coefficient of 8. So let's see, starting with my variable terms, negative 10 and positive 8 gives me negative 2m. And the reason we're doing this, the reason we keep the m attached is because it's almost like you said, well, I have negative 10 m's and I have 8 m's. So if I put all my m's together, how many m's do I have? Well, I have negative 2 m's. All right, so this is kind of like telling you what type of term you're dealing with. Okay, think of it like putting together different kinds of candy bars. So if I have negative 10 candy bars plus 8 candy bars, if I put them all together, I have negative 2 candy bars. Okay, so that's what that variable stands for. It stands for something. Okay, so we combined those, they're done, and now I have positive 3 and positive 9 to give me positive 12. All set there. Let's take a look at 63. Variable term with a coefficient of 3, variable term with a coefficient of negative 6. 3 and negative 6 gives me negative 3, and my variable is p. How many p's do I have? I have negative 3 of them. There's nothing else there, so these are gone, and I'm all done. 64, I have a variable term with a coefficient of negative 4, and a variable term with a coefficient of positive 4. When I combine negative 4 and positive 4, different sign subtract, that just gives me 0. All done. How many x's do I have? 0 x's. I don't have any more. I had positive 4 and I had negative 4, but when I put them together, they canceled each other out and I don't have any more, so 0 is the answer there. Now, variable term with a coefficient of negative 5, variable term with a coefficient of 4. Negative 5 and 4 combine together to make negative 1, keep the variable. Now, you might see it written as negative 1b, or, because it's kind of understood that if the variable is there at all, you have one of them. And then if you have more of them, you can tell how many you have. But if the variable's there, the one is kind of like a duh. Of course you have one, that's why you wrote it. So it's not always written. So you might see it written as negative b, and these are the same thing. Okay, let's do one more. Variable term, the coefficient of 1. It's not written because it's kind of like, duh, you wrote the variable there, so of course you have 1. Then you have a constant term of negative 4 and a constant term of negative 6. So let's see, start with your variable. I only have one n, and negative 4 and negative 6 makes negative 10. So there we go. All right, why don't you take a look at these last few? I think there's 10 of them. Highlight your like terms and combine them, and then come on back for part 2, where we will take a couple of things and wrap them all together in super duper awesome math problems.